This video introduces Transformer, a powerful language model. Combining self-attention and encoder-decoder, Transformer efficiently maps the input sequence to output sequence without using recurrent structure. Transformer is the backbone of all modern large language models. Given an input sequence, a positional embedding matrix is used to embed the input sequence to the embedded distribution. The encoder uses this distribution as the input to generate attention distribution that is used as the input to the decoder. The decoder uses this information from the encoder as the input together with the previous output to generate input to the softmax function that is used to generate the conditional probability distribution of the output word in the vocabulary. Here we give more details about the encoder and the decoder. The first residual of the encoder uses the input sequence as the output. The rest residual blocks of the encoder use the previous output as the input to generate attention distribution. For the first residual block of the encoder given an input sequence, a positional embedding matrix is used to embed the input sequence to embedded distribution. And then I use this embedded distribution as the input to the attention block. We define three matrices, WQ, WP, and WV. Using WQ and the input distribution, we generate a Q distribution. And use the WP and the input distribution, we got the key distribution. And use the WV and the input distribution, we got a value distribution. So start from the first element from the query and the element of the key distribution, we get a normalized distribution. And then we calculate the sum of the weighted value to get one element in the attention distribution. And then we scan all the elements in the query, we get a single head attention. By defining different group of the matrices, we get multiple heads. And then we go back to the residual block of the encoder through this normalization layer. We go through this feed-forward network to generate a result to this normalization. Finally, we get a final attention distribution that is used as the input to the corresponding residual block of the decoder. The first residual block of the decoder uses the information from the encoder together with the previous output as the input to generate attention output. And then the last residual block of the decoder uses the information from the encoder and the information from the last residual block of the decoder as the input to generate input to the softmax function. That is used to generate a conditional probability distribution of output word in the vocabulary. For more details, please check with this reference. Thank you. Bye.